Good morning everybody. My name is Aditya and today in this video we will be looking at retrieval augmented generation. Before we know what RAG is, let us look at LLMs. Large language models are advanced artificial intelligence systems that are designed to understand, generate and manipulate human language. These are trained on vast amounts of data and can perform various tasks such as answering questions, summarizing content, and even generating creative text. Though LLMs are quite powerful, they have some limitations. Two of the most notable ones are hallucinations and outdated information. Hallucinations refers to the instances where LLMs generate information that is incorrect or entirely fabricated. Despite sounding plausible, the generated content may not be based on any real data or facts. This occurs because LLMs generates responses by predicting the next word in a sequence based on the patterns learned during training. This is because the LLM does not check the information against a factual knowledge source. This can have a disastrous impact, especially in areas like healthcare, legal advice, and educational content. This can be quite critical and problematic. The next limitation is outdated information. Now, LLMs are trained on data sets that are static and reflect the state of knowledge up to a certain point in time. That is, they have a certain cutoff date up till which they are trained. This is because the training process is quite resource intensive and expensive. As a result, LLMs are unaware of new developments, events, or discoveries that occur after their last training update. Now, to solve this issue, we have RAG. RAG is a method in NLP that combines the strengths of retrieval-based and generation-based models. It enhances the quality of generated text by incorporating external knowledge during the text generation process. Now, let us look at the basic flow of a RAG. It starts with the user's prompt, which is passed on to the orchestrator, though not shown here, which passes it to the retriever. And the retriever would fetch relevant data, which would be our context. Now, this context can be some data snippet, chunks of data, or paragraphs. Now, this context is passed on along with the user prompt to the large language model. And the large language model would generate a response and pass it on to the user. Now, there are three parts over here. The first part is the retriever part, where the retriever would fetch relevant documents or pieces of information from a large corpus based on the user prompt. Then the augmentation phase would occur. This is combining the user prompt with the extracted content and passing it to the LLM using a system prompt. The last is the generation phase, where the retrieved information is used as the input for the generative model like GPTs, which would create the final output or the response. We will dive further into these parts later on. Now, what problems does RAG help in solving? First, it reduces hallucination. Second, it provides up-to-date data. Third, enhances contextual understanding. And in doing all this, it increases the reliability and trust in the model from the user. And the last point is versatility over domains. RAG can be used over various domains ranging from healthcare to education. What are some use cases of RAG? RAG can be used in various places like knowledge-based question and answering, that is chatbots, customer support for more contextual responses, content creation for checking facts, healthcare and medical advice by giving reliable medical information, legal research and analysis by giving up-to-date information, and personalized recommendations by creating tailored suggestions based on the user's historical data. The first is the indexing pipeline. The indexing pipeline is of four parts: loading, splitting, embedding, and storing. The loading part is where we load all the data. Splitting is where this retrieved documents is split into manageable chunks. Embedding is where the splitted chunks are converted into an dense vector representation using different embedding techniques such as BERT or other transformers. And 4, we are going to store all these embedded vectors in a specialized database or indexing system. Now is a good time to introduce two LLM frameworks that are quite popular to develop LLM powered applications: LangChain and Llama Index. We are going to use LangChain for this demo, but you can also use Llama Index. The first step is the document loading. We can use various document loaders to load data. Now, these document loaders would load data from variety sources, say your Google Drive or CSV, Excel files, and so on. In LangChain, you can use different functions, and in Llama Index, you could use the Llama Hub. Next is document splitting. But the question arises on why we need to split documents. There are two reasons: ease of search and content window size. Now, large chunks of data are quite hard for the LLMs to search over, for the retriever to search, compared to smaller chunks. And the second is the context window size. Some LLMs take only a finite number of tokens in their prompts and completions. So now in the prompts, you could have like a fixed number of tokens that can be passed in, say 2000 or 3000 tokens. To address these issues, we need to split the document into manageable chunks so that they can be retrieved easily and given to the LLM to give more context. Now, how would we do document splitting? We would split documents using different splitters like split by character, recursive split by character, and different tokenizers like TikTok tokenizer, Hugging Face tokenizer, and other libraries. The next step is the embedding step. In this step, each chunk of text is converted into a vector representation known as an embedding. These embeddings capture the semantic meaning of the text, making it easier to compare and retrieve similar chunks during the retrieval phase. Now, let's take an example of fruits. So, say you have different fruits like apple, banana, orange. Now, in the vector space, these points would be grouped together. But a different idea, say like a mobile phone, would be far away from the vector points of these. Some of the popular embedding models are Word2Vec, Glow, FastText, Elmo, BERT, Ada V2. The last step in the indexing pipeline is the storing step. In this step, we are going to store the embeddings along with the original text chunks in a vector database. This database is designed for fast retrieval of relevant information when a query is made. Now, we are going to store all the embeddings in a specialized vector database so that we can get the data as soon as we are given the user prompt. Some popular vector databases are the Facebook AI Similarity Search, Pinecone, VV8 and Chroma. Next on, let us move on to the RAG pipeline. The RAG pipeline has 3 steps: retrieval, augmentation and generation. The pipeline starts when a query is inputted into the system. This query would represent a request for the information or a prompt that the system needs to respond to. Next, the retrieval. The retrieval phase, the system uses the embedding stored in the vector database to find and pull out chunks of data that are most relevant to the input query. Next, in the augmentation phase, after retrieving multiple chunks of information, the system may augment this information by enriching or enhancing the retrieved data to improve the relevance and quality of the final input. The last step is the generation phase. The augmented information is fed up into the generative model like GPT, which would generate a response, which is passed on to the user. Now let us look at a demo. Now on to the practical. We are going to have two files. The create database file, which would be acting as an indexing pipeline, creation of the database, and second, query data, which should be our actual RAG flow. Along with this, I'm going to have an .env file which should store all my keys and endpoints, because I'm going to be using Azure OpenAI for the embeddings and the LLM. My data is stored in the data/books folder, and the data is nothing but a markdown file of the book Alice in Wonderland. First, let us look at the create database.py. First off, I'm going to import the dependencies. Next, these lines would load the environment variables from the .env file. In this case, we are going to load the Azure OpenAI API key for the embeddings. Next, I'm defining the path in which I want to store my ChromaDB and the path of the data. The flow starts with the main function. I'm going to call the generate data store function, which in turn calls the load documents function. Here I'm going to use the unstructured markdown loader, which is a document loader from LangChain for loading markdown files. I'm going to pass in the data path. After the documents have been loaded, we are going to pass them into the split text function for conversion into chunks. The function that we are going to use is the recursive character text splitter. I'm going to define a chunk size of 300 characters and an overlap of 100 characters for better context. After returning the chunks, I'm going to save them to the Chroma database using the save to Chroma function. In this function, first we are checking whether the Chroma directory exists or not. If it exists, we are going to delete it. Next, we are going to create an ChromaDB using the from documents function. Here we are passing in the chunks and the embeddings model, which is Azure OpenAI embeddings that I'm using over here. Next, I'm setting the directory to the Chroma path, which is defined as Chroma. Lastly, we are going to print the number of chunks that were saved to the directory of Chroma. Let us try it out. It might take a while because the file is really large. There you go. We have created our ChromaDB. You can find it as in SQLite 3 file. Now on to the query data.py. Similarly, first we are going to import our dependencies and we are setting the Chroma path. Next, we are going to load the environment variables from the .env file. Here I am going to load my Azure OpenAI key, then the endpoint and the version. Let us skip to the main function. First, we are going to take the user's prompt using the input function and storing it into the query text variable. Next, we are setting up the embedding function, which is nothing but the Azure OpenAI embeddings, and the model that I am going to use is text embedding adder002. This would be a deployment name, but I have given the deployment name and the model name as the same. Also, I am passing in the Azure endpoint and the API key and the OpenAI API version. Next, I'm going to connect to the already existing ChromaDB. Now, we are going to use the similarity search with relevance score function to get the top 3 contextual responses based on the user query. What it would do is it would search the query against the stored vectors, and it returns the top 3 most relevant chunks based on their similarity scores. Now the results are saved to the results variable. Next, we are going to check whether the results are equal to 0, that is, we have no matching results, or the confidence score is less than 0.7. We are going to return unable to find matching results. This would help us give results that have better context. This also helps reduce our hallucinations. Next, we are going to format the context text in a proper format, and we are going to use the prompt template given below. Here, we are going to fill in the context. After we get the formatted prompt, we are setting up an Azure OpenAI client by passing in the endpoint API key and version. Then we are going to use the create function from clients.chat.completions with the given deployment name of GPT-35 Turbo 16K, which is also my model, and in the messages I'm going to pass in the content as the prompt. Next, I'm going to get the response and I'm storing it in the response text variable, and then we are going to format it along with some sources, that is nothing but from where we have extracted the context from. This would help make the response more reliable. Now let us test it out. The prompt that I am going to enter is who is the author. There you go. It has extracted the author's name perfectly from the given data. It has also understood to what book we are referring and who the author is. There you go. The author is Lewis Carroll, which is correct. I have only one book, so it is returning the sources as the same book name. But if you have different markdown files or and a higher number of documents, it would return exactly which document it has taken it from, and you can also mention the index in the metadata if you want to get it. So in this video we have covered what RAG is, the different components of RAG, and an hands-on demo on RAG. I hope you liked this video and please do subscribe.